Hello, so we're back, and this time we have a nice laptop to repair. Check here. ROG Strix G i7 9 Gen and NVIDIA graphics. 144Hz display. So this is a proper nice gaming laptop, 17-inch screen. So what's the problem with this one? The problem with this one, this laptop is coming from a computer business, which they send me more jobs, but this one, fault, not power at all. So this laptop has no power at all. We are not plugging the power because we don't know what is wrong inside. I will say let's open first and check the main power rail. And the laptop is open. This is a nice motherboard. So what can be wrong here? I mean, it looks like someone worked here or what? Anyway, let's check the main power rail. That's the first thing what we are checking. Can you spot anything wrong here? Let me unplug the battery. The main power rail coil to MOSFET's capacitor. The main power rail has 0 ohms, you can see on the screen. So the main power rail, it is shorted. We can also check the main power rail. You have here charging port, you can see, charging port, first MOSFET, second MOSFET, current sensor. So we can check here, 0 ohms. So the main power rail, it is shorted. Now, before we are taking out the heatsink, I'm just curious what can be shorted. Let's lower the power supply voltage to 0.9 volts. So we have ground. Let me grab the thermal camera. So I will come with current after the current sensor here. Or I can come there. It's not even important. We can come here. So here the voltage is 0.4 and on the other side 0.2. So here is the plus. Okay? Good. And the question is, what is getting that kind of current? Can you spot anything? Let me raise the current. Maybe you can spot something. Huh? What about now? Now you can spot something? It's looking obvious to you? What is there? Here somewhere, right? Okay, let me take out the heatsink just to have a better picture. And the heatsink, it's out. Little bit of dust. Even here, not too much, but you know, enough to raise the board temperature. Now one more time, because now we have space. So coming with current after the second MOSFET and the component, check there, you can see it. Which one it is? It's exactly at my finger. Here. So let's go under the microscope and check with alcohol. I mean, it's not even point checking with alcohol. You can clearly see the capacitor has a crack on it. You can see it? Yeah. But yeah, let's try with alcohol. So coming with alcohol. Now, power on. You can see the capacitor. The alcohol is getting quickly evaporated from the capacitor. Yeah, that capacitor is gone. Let's remove the capacitor. And the capacitor is removed. So what do you think? It will work or not? That's my question. What do you think? Let me just put the heatsink for testing. Then we can replace the thermal paste and clean the heatsink, the dust. Perfect. So I'm gonna plug the battery. The battery is plugged. Let me grab the charger. Before we are plugging the charger, we can check one more time. No short, so it's not short anymore. Now plug in the charger. The charger, it is plugged in. Let's see, what do we have? I can't see the charging light. So this laptop actually doesn't have a charging light? Okay, let's press the power button. Pressing the power button. And nothing. Huh? 1 second. 1 second. Let's check the voltage on the main power rail. So the main power rail voltage is 4 volts. What? Why the main power rail is 4? The input voltage is 19.8. So we have 19.8 at the other charging port. And following on the input of the first MOSFET, we have 19.8. On the output of the first MOSFET, we have 0 volts. So we have no voltage passing the first MOSFET. So you see, on this case, we have a second fault. Let's have a look. I think it's making sense. So someone worked here. Clearly, you can see someone work here. I mean, they missed the capacitor. Let me plug the charger and let's check one more time. So on the input of the first MOSFET, we have 19.8. On the output, we have 0. On the gate, we have 0. So no voltage on the gate. Nothing. Yeah, so someone, work on this input circuit. Yeah, this is something what is pissing me off. I mean, the fault was clear, you know, simple. No headache. Let's check the MOSFETs. First MOSFET is shorted. First MOSFET is not shorted. The second MOSFET is not shorted. Gate to source is not shorted. And probably gates are together, right? Yeah, the gates are together. So here is no issue. The problem is around the BQ chip. But before there, I'm assuming this is the resistor. You can see from the main power rail is coming to this resistor. I'm assuming this resistor is providing voltage to the BQ chip. And there's no voltage here. It's no resistance. Not sure what resistance this should have. Not sure what circuit is this. But this is blow up. Check there. Has a black mark on it. It is blow up. I can't believe. So this thingy, the mark on this thingy, check here. This hole. This is blow up. Whatever it is. I mean, not sure what this is. Check here. You can actually see the components inside. Check on the screen. I have like 180 ohms from this hole to a pin. So this is exploded and I'm not sure what it is. But let's plug the charger and see what that is doing. So plug in the charger. Good. Let's see what it's doing. The charger is plugged. Here, obviously, we have 19.8 and here we have 0 volts and that's not normal. Yeah. So we have no voltage here. I will unplug the charger. Let's check to ground. So this one to ground, I have 175 ohms. This to ground, nothing. This is ground, 3 ohms, 0 ohms. So this it is ground. Here is no ground, here is ground. So what this thing is doing here? Why I have no voltage drop? I have no voltage on the other side of this resistor. Anyway, if you see the video, Just let me know in the comments what is that thingy. It does matter? No, really. We have to focus on getting the input circuit working. So I'm assuming this track or somehow the bigger chip is taking power from here. But let me grab this out. Let me take this out. Yes, I got this out. Which again, I'm not sure what it is. And what I have no idea what it is. Let me plug the charger. Plug in the charger. Let's check the voltage. So here we have 2 volts. You think this resistor actually is burned? I mean 2 volts. So here is ground. Here I don't know what it is. Here it's a resistor which is providing some power to this whatever it is. Okay, so let's leave this on one side and let's go to the BQ chip. Okay, so the power management chip is here. I mean, I don't have to take the motherboard out. We have the BQ chip. Here, the charger, it is plugged. Let's check the voltage on this chip. So the voltage, yeah, this is pretty straightforward, right? So we have this double diode here. You can see it, this one. And we have 19, lol. And here we have 19. So the BQ chip has power. Huh? Why then I have no voltage on the gate? AC detect. Let me check the datasheet of this chip. I remember it was like pin number 6, if I remember. Pin number 6. Let's see this one. No, actually probably it's pin number 5. I can see a divider here. And we have 2.6 volts. So the AC detect is present. You know what? We cannot fix laptops like that. And I said that many times. I can't fix something if I don't see the current. You know, we are like blinds. So let's come with the power supply. Let me switch to 19. Let me lower the current. Yeah, but it's kind of low anyway, right? Yeah. So coming with voltage here, and it's taking nothing, absolutely nothing, no current. You can see 0. Coming with 19 volts here, and it's fine. It's nothing shorter on the main power rail. On the middle of the MOSFETs, and the motherboard is starting. If I will be dodgy, I will short the first MOSFET. And the laptop is on and working. I can't believe. What a picture! So you understand? I just made a bridge from the charging port, from the plus to the current sensor. If I take out the bridge, the laptop is switching off. So we know the laptop is good apart from the input circuit. Okay, so the VCC is present. We checked. We seen there the double diode. So we do have voltage on the BQ chip. The AC detect, we do have like 2.6 volts, which is fine. So having this, we should have this BQ chip working, and it's not working. Reg N, let's see Reg N. Reg N, 6 volts linear regulator output, supply from VCC. The LDO is active when AC detect above 0.6 volts. Good, so pin number 24, let's see. Must be here, this one. And we have, 1 second. We have what? We have 6 volts, lol. So everything seems to be fine inside of this BK chip. But pin number 4 is 0 volts. So we should have 25 volts on that pin, because the gates of the MOSFET, they are channel N MOSFET, so should have 25 volts. I'm really sorry, but I can't see what we can do apart from replacing the BQ chip. And we have a brand new BQ chip here. Perfect. And the BQ chip, it is soldered on place. Now let's cool the board and test it. Good, let's plug the charger. So the charger, it is plugged in. Now let's check the voltage. The main power rail voltage is 3.9. The gate of the MOSFETs is 0. Interesting. And on the BQ chip, what do we have? Input voltage, 19. AC detect, 2.6. Reg N, 6 volts. Okay, that sucks. Yeah, I think it's this one. Yeah, check here. Yeah, making sense now. So our component which is burned is this one. Overpower protection circuit. So how this is working? So means if the voltage is going up here, it will output 0.6 volts on this transistor and it will short. No, actually this pin has to be dragged down because it's always high, right? Yeah, 100%. Yeah, let's find this transistor. Actually, we don't have to find that transistor. Let's check pin number 1 from the chip we removed. Yeah, that can make sense. So here on this circuit, we have, what do we have here? Here we have 14 volts. Okay, this pin has to be to ground here. And if it's to ground, let me see what will happen with the main power rail. If this is connected to ground, the main power rail, nothing changed. P-charge AC MOS. Yeah, okay, so basically, what will happen? What will happen if you have a over voltage? This transistor, it will switch this track to ground, yeah? P-charge AC MOS G20, which is this one, which is basically the gates of the first MOSFETs. So that transistor, it will switch to ground, the 25 volts power from the gates. So if we remove the chip, what do we have to do? Because the transistor is biased through this resistor, so we have to short the base of the transistor to ground, or remove the transistor totally. Not sure if this transistor is good. I don't even know where it is. Okay, so check here, yeah? This is an NPN transistor. It's biased through this 470 kilo ohms resistor. So basically, what is the voltage on the base compared with the ground? 0.6 volts. Yeah, this is an NPN transistor. Let's check what do we have here. So pin number 2 of that chip, which is going to the base, yeah, is this one. And we have 1 volt. Which make me believe actually our transistor is dead. I don't know where is the transistor, that's the problem. So here, probably is going on the other side of the board. So I'm gonna take the board out, because this transistor is shorting me the gates of the MOSFET. Yeah, this is liquid damage, right? Check there, and here. Yeah, this is some liquid damage. But it's okay, it's nothing important there. Okay, let's try to find our transistor. And I think I found it. Yeah, I found it. So the transistor is removed. Good, perfect. So what about now? Hopefully now it's working. We don't even need a laptop. Let's see, so plug in the charger. The charger is plugged. Let's check the voltage. Main power rail, 19.7. Huh? Check that on the screen, 19.7. Lol, the motherboard is on. The input voltage, 19.7, and the output, 19.7. And the laptop is fixed. Let me put back the motherboard quickly. Plug in the battery. Plug in the charger. The main power rail, 19.6. Oh, and the laptop. That's crazy! What is this sound? You heard the sound? Tell me you heard the sound. If you didn't, I will do it one more time. Yeah, that's the sound. Keyboard is working. Yeah, keyboard is working. Mousepad is working. All good. So I'm gonna stop the video now. I'll put it all back together, replace thermal paste, clean the fans and everything. Now, why the reason why this fault occurred? Or what will happen with the capacitor and the removed chip and transistor? Well, I'm not gonna replace them, yeah? I don't believe in overvoltage protection circuits. We made a video a while ago testing the laptops, and the laptops, I tested a laptop and the laptop was working fine up to 25 volts. The switching power supplies, they are not like 19 volts switching power supply chips, so they can work probably over 25 volts. Definitely over 25. But if you have like you have a specific chip meant to detect high voltage, that chip should work a lot higher voltage, and our chip was blow up. You know what I mean? So clearly this chip didn't blow up from high voltage. I still believe the initial fault was actually a capacitor. Then someone play around the input circuit because the voltage was missing on the gates. On the gates, which you have 25 volts, like how I said, we can check that. But that transistor from the other side of the board, it was shorting the 25 to ground. So on the gate, we have, check on the screen, 25.6, you can see. So that's the voltage which is coming from the BQ power management chip. So I will say thank you for watching, like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.